Example 2, the power rule for negative and fractional exponents. So we're going to differentiate a and b. So let's go ahead and do that. So for the first one, we want to find f prime of x, meaning the derivative. And so we want to find d with respect to x. Okay, so this is 1 over x to the second power. We can rewrite this as x to the negative 2. And so therefore, if we want to use the rule for the derivative, n is negative 2, and that's x to the negative 2 minus 1, which then is equal to negative 2x to the negative third power, which means in the numerator we have a negative 2. We want to write positive exponents, so this is negative 2 over x cubed. So now let's take a look at part B. Okay, we want to find the derivative, which is y prime, which is the same thing as dy over dx. And we're going to rewrite this as a fractional exponent. So this is the same thing as x to the 2/3 power. So the value of n represents 2/3. So we have 2/3 x to the 2/3 minus 1. And so now we have fractional exponents, and so we need to combine those fractions. So this is 2/3 minus 3 over 3, which then equals 2/3 x to the negative 1/3. Or if we wanted to simplify this further, this would be 2 over 3x to the positive 1/3 power. But we can leave it in this form. Now in part B, let's graph its function and its derivative. So we're going to graph it on Desmos. Okay, so we know that this is the cube root of x squared, or we can say that this is x to the power of 2/3. And then we have the derivative, which is 2/3 x to the power of negative 1/3. Okay, so let's take a look at that function. Okay, let's go ahead and copy this graph, elaborate a little bit more on it. So again, this is for part B. So we know that the blue graph represents y, which is equal to the cube root of x squared. And we know that the derivative is the green, where y prime is equal to 2/3 x to the negative 1/3. So if we elaborate a little bit more on it, okay, notice that y is not differentiable at 0 because y prime is not defined there. And if you recall, that is a corner. Now observe that y prime is positive when y increases and is negative when y decreases. So when the function y is decreasing, we can see that the function is below the x-axis, which is negative. And if the function y is increasing, then we can see that this graph is above the x-axis, so therefore it's positive when y is increasing.